All right, so let's figure out for this kitty head, let's figure out what the net moment is of a couple of forces that act around point B for this kitty head. All right, so we have two forces, it looks like. We have F and we have W. Let's go ahead and write those on here real quick. So we have F is equal to what? 50 newtons. And we have W is equal to what? 120 newtons. Okay. Theta right here is equal to 25 degrees. All right. What it's asking for is the net moment of these two forces around point B. Okay. So we'll figure that out. As we sum these moments up around point B, we need to pick a direction we're assuming is positive. Okay. What direction would you like to assume is positive? Okay. Counterclockwise sounds good to me. Okay. So W is a force of 120 newtons. How far is the line of action of that force, 120 newtons, away from point B? Okay, it's this distance right here, 0.5 meters. So I'm going to take that and multiply by 0.5 meters. Does that tend to try to rotate the body counterclockwise or clockwise around point B? Okay, it should be counterclockwise, so how should I count this according to my direction I've assumed is positive? Positive, right? So I've got the correct sign on there already. All right, what's next? Okay, so we have at point A, the thing is at point A is that we have two components of force acting at point A. We have both a horizontal component as well as a vertical component. And just so that I don't have to keep saying that, let's go ahead and name this X, and we'll go ahead and name this right here Y. So I have an X and Y component that happen at point A. Okay, which one do you want to deal with first? Okay, someone says X. So I'll tell you what, I'm going to show these on here like this with an orange color. Okay, the X component right here is going to be equal to what? 50 newtons times the cosine of 25 degrees. There's another component that acts right here, and that's going to be what? 50 newtons times what? The sine of 25 degrees. Okay? And I need to deal with each of those separately. So let's deal with the horizontal one first. Okay? First of all, does it tend to try to rotate clockwise or counterclockwise around point B? Clockwise, which means since I'm taking counterclockwise as positive, I'd better put in a negative 50 newtons times the cosine of 25 degrees times what? Okay. All right. What I need to do there is figure out how far is it from point A down to point B. Well, how do I figure that out? Okay. We look at the picture. Okay. Okay, so we actually, what it looks like here is that we do not know the distance that goes from here to here. We know that it's 1 meter from here to here, correct? But we don't know this other distance. Okay? So what would your response be at this point if you were taking this exam?
Just to use a meter and keep it.
Okay, I'll tell you what my response would be. My hand would go up, and I would call the proctor who's in the room over here and say, I don't have this length right here, and I think I'm supposed to. And what do you think your proctor would say? Okay, they'd have to say something, right? There is not enough information given for this problem. Okay, let's actually make something up so we can finish the problem. I don't actually remember what the I don't remember what the answer was to this. There's obviously something built into it. Okay, we could try to reverse solve it and try to figure it out that way. What you got?
Well, I tried solving it and it got 10.46.
Okay. All right. He tried solving it and he got one of the answers. What did you use as far as what I'm trying to come up with right there? The length from the line of action of the horizontal component of the force acting at A down to point B.
Well, it looks like they just put 1 as a constant, like going that distance.
That 1 went all the way down to B?
Yeah.
Okay.
That's what I had on my work. Got that answer.
Okay. That answer doesn't make a lot of sense to me as far as like physically, but that's one way that you can try to get the answer that's in the choices. I don't remember perfectly what happened with this question as far as during this particular exam that was given, but there are times where this type of thing is discovered in the process of giving the exam, and either the question is thrown out, we tell people don't answer that question, or we give them another piece of information that helps them to answer the question. So, that's about as good as I can do, right? Is just say, make this known to your proctor if you end up with a situation like this, and that's about as good as you can do. This was not an intentional thing, I imagine, that this showed up like this, but it's a good thing to discuss. Is like, there's this kind of thing, people who write these tests are human beings like anyone else, and they have a tendency that they could make mistakes, and so if you are actually, it's actually a really good lesson about real engineering work too. Life doesn't make sure you have the exact parameters that you need to solve the problems, right? So this actually reflects a real life situation in one way. It's different in that, real life kind of gives you a chance that you can go back and figure out what the things are that you're missing so that you can come up with an answer. So anyway, yes? Mm-hmm. Okay. The first thing I would want to know is this an accurate picture? Right? If you're not given anything else, the best you can do is look at the picture and say, if this is drawn to scale, right, then my length here, 0.5 meters going from B to this center point horizontally, maybe I'm at 0.5 meters going down right here too. Right? And if I've got 0.5 meters going down right there, right, which is about as good as I can do if I'm trying to answer this question, in the absence of really knowing, right, then why don't we solve that question, right? We probably won't get one of the answers that's in the answer bank, but we'll go ahead and solve this one so that you see what to do. Okay? So this ends up being times 0.5 meters. Now, 0.5 meters plus 1 meter, right? 1.5 meters. Okay, then what else? Okay, the next one, you basically look at this and see that since 0.7 meters is larger than 0.5 meters, it means that the line of action of this force right here does lie to the right of point B because 0.7 is larger than 0.5. Okay, that tends to try to rotate it clockwise. So I say minus 50 newtons. Tell you what, I'll do it down here. Minus 50 newtons times the sine, 25 degrees, times what? Okay, 0.2 meters, and where you got that was from 0.7 meters minus 0.5 meters. Okay. Now, since this is not an equilibrium problem, you don't set this one equal to 0, right? What you're trying to do is actually come up with a net moment that may not be 0 for this particular type of problem, okay? So I go ahead and punch these in. Say we got 120. Go ahead and punch them into my calculator here. 120 times 0.5 minus 50 times cosine of 25 times 1.5. And the next one is minus 50 times sine of 25 times 0.7 minus 0.5. And that gives me negative 12 we'll say just 12.2. And what are the units? Newton meters. Okay. 12.2 Newton meters is what comes out of this. What direction? Okay. Okay, I'll say over here the negative means opposite of counterclockwise. Which is clockwise. Okay, so we would answer here. We've got clockwise, and given the fact that the question actually asks the net moment is closest to, there's technically a right answer. Do you agree with that? What is technically the right answer?
See, that's what I did it as 1.5, and I got that, but apparently it was 11.31 in counterclockwise.
Yeah, I mean, there was obviously something missing in the problem,
Yeah.
right?
And then I was
So,
looking at a lot of numbers, and like, you'd have to go below 1 meter to get the answer that they had.
yeah.
Is there a solution?
That makes no sense.
What's that?
Was there a solution for this one?
No, it was a messed up problem. So there wasn't a closed form, good solution for it.